Assalamu alaikum students. In our today's lecture, we will study about different methods of electric heating. As we can say that heat is produced due to the circulation of current through a resistance, and the current may circulate directly due to the application of potential difference, or it may be due to induced eddy currents. Uh, as we can say in magnetic materials, hysteresis losses are used to create heat, and in dielectric heating, molecular friction is employed while heating the substance. An arc established between an electrode and the material to be heated can be made a source of heat, bombarding of bombarding the surface of material by high energy particles can be used to heat the bodies, as there are different methods to heat the different bodies. Room heater is a familiar appliance where electric heating is employed. In most of the houses we use the room heaters. And we say in electrical technology, different methods of producing heat for general, industrial, and domestic purposes may be classified as in this figure you can show. See, you can see that electric heating is can be produced by using power frequency heating methods and high frequency heating method, and these are divided into different methods. And power, if we take power frequency heating, it is subdivided into resistance heating and arc heating. And if we further uh, go check out, take the resistance heating method, it is based on the I square R effect, as it's we know that the formula of power. When current is passed through a resistance element, I square R loss T losses takes place, which produces heat, and this produced heat we can take two different methods of producing heat. There are which we can say that direct resistance heating and indirect resistance heating methods. If we say in the method of direct heating process, in this method, the material or the charge to be heated is treated as a resistance, as we can say that the material which we have to heat up or the charge, we will treat it as a resistance, and current is will be passed through that material, and the charge may be in the form of powder, which is a small solid pieces or liquid. The two electrodes are inserted in the charge and connected to either an AC or a DC splices in power supply. And if we say that in case of DC, AC or DC supply, obviously two electrodes, as we can say in this figure, two electrodes will be required in the case of if it's we use a DC supply, then there will be the requirement of two electrodes. Or if there is a single phase AC supply, we will require two electrodes. But in case of three phase supply, we will require three electrodes. And when the charge is in the form of small pieces, a powder of high resistivity material is sprinkled over the surface, as high we see in the blue bubble type material. This is high resistance powder, which is used to which is sprinkled over the surface of the jar to avoid direct short circuit. Heat is produced when current passes through it, and this method of heating has we can say high efficiency because of the heat is produced in the jar itself. That the jar which is present, heat is produced in that jar, and it is a high efficiency method, and heat is very minimum heat is loss, as we can say the losses are very minimal amount. So the efficiency is increased by using this process of direct resistance heating method. And if we say in the method of indirect electrical heating, this is the most common method of heating. Electric current is passes through a resistance element which is placed in an electric oven. As we can say that current is passed through a resistance element, as this we can say in this figure, which is placed in an electric oven. Heat produced is proportional to, and with the heat which is produced is proportional to I square or losses in the heating element. And so we can say the heat so produced is delivered to the charge either by radiation or convection or by a combination of the two these charge. And sometimes resistance is placed in a cylinder which is surrounded by the charge placed in the jacket, as we can say in this figure. And this arrangement provides uniform temperature all around this jacket area. And moreover, atomic temperature control can also be provided. And this environment, we can say, this in the controlled environment we can produce heat in by using this indirect method of electric heating. So we by using this indirect electrical heating method, heating is this indirect heating is based on heat produced in a conductor carrying a current. The heater is away from the work, and the heat transfer takes place by conduction or radiation process. If the resistance of the conductor, if we say, is R ohms, and our current is I amperes flows through it, for a time t seconds, the heat produced, we will say, will be equal to I square R into T joules. And power dissipated, we know that is equal to P is equal to I square R watts. So P, and we also know that P is equal to I cross V, and so it will be equal to V square over R, where V is the voltage across the conductor. We can say the potential difference. The conductor is called the heater or heating element, or we can say that conductor are simple an element. And these are the different indirect electrical heating methods, and or heaters, we can say, which uses this method of indirect electrical heating. And as we can say, these two rods are placed in a water or a liquid to heat that thing. And these different electrical indirect electrical heating methods which are used to heat the materials, the liquids in our daily use. There are different requirements of good heating for a good heating element. These requirements, if we consider, according to these requirements, indirect resistance furnaces use many different types of heating elements and for producing heat. And a good heating element which is used in these methods of indirect electrical heating will have some properties, and some of those properties are listed here. And we can say high specific, there should be a high specific resistance, that when specific resistance of the material of the wire is high, only short length of it will be required for a particular resistance, and hence heat are for the same length of the wire, and current heat produced will be more. And as we can say, for a high specific resistance, if the resistance is high for that element, the resistance produced will be in more and more as compared to the low specific resistance elements. And if high melting temperature, if the melting temperature of the heating element is high, it would be possible to obtain higher operating temperatures to, for example, to work out at the areas of high temperature. Low temperature coefficient of resistance, and if in the case of low temperature coefficient of resistance, a material has low temperature coefficient, there would be only small variations in its resistance over its normal range of temperature. Hence, the current drawn by the heating element when with cold that is at the starting point, would be particularly the same when it is at the hot stage. And high oxidizing temperature oxidation temperature of the heating element should be high in order to ensure longer life of the material or heater to use. Positive temperature coefficient of resistance. If the temperature coefficient of the resistance of heating element is negative, its resistance will decrease with rise in temperature and will draw more current, which will produce more wattage and hence heat. With more heat, the resistance will decrease further, resulting in instability of the operation. So that's why we say that the temperature coefficient of resistance should be positive, and so that the results of the operation and there should be a stability in the operation of heating. Ductile, since the material of the heating element has to have convenient shapes and sizes, it should have high ductility and flexibility so that we can be used, these heaters can be used at high ranging temperature environments. Mechanical strength, there should be mechanical strength. We can say the material of the heating element should possess high mechanical strength of its own. Usually, different types of alloys are used to get different operating temperatures. For example, minimum working temperature of constant, or for example, if we say that in the cases of nickels, it's 45%, and for copper, 55% is constant, which will be 10 is 400 degrees centigrade. That of nichrome uh, is const, constant, and 400 degrees centigrade. And for nichrome, in the case of nichrome, it's 1150 degrees centigrade. That of Kantha, which uses the formula of, if we say, ferrium, chromium, aluminium, it's 1200 degrees centigrade, and that of silicon carbide is 1450 degrees centigrade. With the passage of time, every heating element breaks open and becomes unserviceable. Some of the factors responsible for its failure, we will say that these are formation of hot spots which shine brighter during operation, oxidization, corrosion, and mechanical failure are the causes of the elements to be to become unserviceable. So these are the different requirements of for the good heating elements. If next we will move to the resistance furnaces or ovens, we say these are suitably insulated closed chambers with a provision for ventilation and are used for a wide variety of purposes, including heat treatment of metals like annealing and hardening, etc., stoving of enameled wares, drying and baking of uh, potteries, vulcanizing and hardening of synthetic materials, and for commercial and domestic heating purposes. Temperatures up to 1000 degrees centigrade can be obtained by using heating elements made of nickel, chromium, and iron, and ovens using heating elements made of graphite can produce temperatures up to 3000 degrees centigrade. Heating elements may consist of circular wires or rectangular ribbons. The ovens are usually made of a metal framework having an internal lining of fire bricks. The heating element may be located on the top, bottom, or sides of the oven. The nature of the insulating material is determined by maximum temperature required in the oven. An enclosure for charge, which is heated by radiation or convection, or both, is called a heating chamber. And why using these heating chambers. Okay, these are the different requirements for the, we can say, heating element used for the furnaces to heat up different materials, and that how there should be the, we can say that heating chamber and range of the materials which are used to made up these chambers, and how much maximum heating they can produce. We discuss in this lecture. And inshallah, in our next lecture, we will see that how we can control the temperature of the resistant furnaces, and which things are used. So inshallah, we will look forward for the next lecture. Take care, students. Allah.